Are you tired of manipulating data in Excel week after week, month after month? Do you want to learn one of the most popular, tried and true methods of coding out data manipulation known to analysts? A tool that has become a common language across other analytics platforms like SAS, R, Python, Alteryx, Power BI, and Tableau, and so many other platforms as well. If so, you're in the right place, and today is the day to finally learn SQL. Hi, I'm Brian Amrine with Value Driven Analytics, and in today's training session, I'll start by providing a little bit of context around SQL, and then we'll dive right in to a hands-on analysis that you can follow along with on the relationship between weather and stock market performance. We'll look at whether the stock market generally performs better when the weather is nicer. Hey, it's a pretty nice day. Things are looking up. I think I'll buy some stock. By the end of this session, you should have a solid foundation for performing all kinds of data manipulation tasks in SQL. If that sounds good to you, let's get started. When it comes to data manipulation, SQL is truly a staple. As I mentioned before, it can be ran in all kinds of other analytics platforms. In fact, there are quite a few SQL-specific platforms, such as on-premises data platforms like Teradata, Microsoft SQL Server, Oracle, and so many others. And over the last 10 years or so, big data platforms have also spun up, such as Azure and Snowflake and HiveQL, and many others as well. These allow analysts to use cloud computing to apply traditional SQL syntax to billions of rows that process in seconds. Today, we're going to be running SQL within Python and a Jupyter Notebook specifically, using a Python package called pandasql. It essentially allows us to write SQL against a pandas data frame to create another pandas data frame. This is just another example of how SQL can be used within nearly any other analytics platform. There are several slight variations of SQL across the different platforms that it can be ran in, but usually the basic components that we'll cover today are similar or the same across those different versions. Only things like date and ranking functions and things like that can sometimes be different. The particular pandasql package that we'll be using in Python today uses a version of SQL called SQLite 3. As we'll see in our demo today, SQL is especially good compared to other analytics tools at grouping and aggregating data, merging tables together in a really flexible manner, and creating new columns. It really is quite flexible as a data manipulation tool, second only to perhaps advanced analytics tools like SAS, R, and Python that have additional capabilities of doing things like pulling data from an API directly, looping and iterating over data manipulation tasks. Now, in some cases, a SQL query might be written for an ad hoc data pool to provide data to a particular stakeholder. And in that case, the SQL query would be written, it would be ran within a certain SQL platform. The data table that would result from that SQL query would be copied and perhaps pasted in Excel in a data tab, a data worksheet within that Excel workbook. And what you might do, what I would recommend doing on top of that, is creating a SQL tab as well and taking your SQL code and putting it in another tab. That way, if the stakeholder ever needs that data again and they reply back and say, can you recreate this or update this, you've got the SQL query to run right there in the SQL tab. Even better though would be to schedule your code in another platform. Perhaps an interactive visualization platform like Power BI or Tableau. Or perhaps you embed your code in a scheduled Python job. Either way, you can set up your SQL code to run on a regular basis or at a stakeholder's demand. SQL is really powerful for automation. While SQL is very useful for data manipulation and data analysis, most data science models cannot be built using only SQL. However, SQL is extremely useful for creating the data set that a data science model might be trained on. Now that we've gone over some context around SQL, let's head over to valuedrivenanalytics.com and download the data sets that we'll need for our analysis. Well, here we are on valuedrivenanalytics.com, ready to download the files that we'll use for our analysis. So in order to do that, once you're on the site, go to Analytics Training and then Intro Data to Data Analytics. Now from there, we'll scroll down and go to our SQL training session. Here it is right here. And on this page, you'll find a few files that we need to download. The stocks.xlsx Excel workbook, the weather workbook as well. And then there will be here, it's not here currently, but when you go to the site, there will also be a weather versus stock market performance Jupyter Notebook. That'll be the Python notebook where we'll be running our SQL code. And if you have not downloaded Python or Anaconda in the past, you'll want to download that as well before the section where we actually get into the analysis. So in order to do that, we have a PowerPoint that'll walk through how to install Anaconda. It'll get you all set up. An alternative to this would be to scroll over right on the side here and go to our Introduction to Python course. And I'll put in the description the exact part of that video that covers how to install Anaconda. So whether you walk through the PowerPoint or you go into the video and watch how it's done and follow along that way, you'll want to install Anaconda, which will install Jupyter and Python, and that'll be where we actually run our SQL code today. Now, you don't have to download that if you don't want to follow along with the SQL analysis portion. If you just want to watch, that's okay. But I highly recommend following along, and you'll need Anaconda installed to do that. Now, before we get into our analysis, let's take a quick look at our two data files in Excel to start off with. The first one is going to be the stocks.xlsx file. Here, we're looking at a particular stock index. It kind of mimics the S&P 500. It's called, the symbol is SPY, and it essentially has one row per day that the stock market is open. So it would exclude any weekends, it would exclude days that the stock market is closed, but it would have any days that the stock market is open. It'll have one row per day. And it goes all the way through May 1st through April 30th. In this case, May 1st was a day when the stock market wasn't open. And it'll have the opening SPY price, essentially, and the closing SPY price. Again, a proxy for the S&P 500, which is a set of large corporations and how their stock prices are doing over time. And then you can see we have another column here that I've gone ahead and created that represents the previous close. So as you can see, 404 for the May 3rd row, and that represents what the close was on the previous day, 404 right here on May 2nd. So it just tells us that previous day's close, the previous day that the stock market was open. So that's our stock data set. And we'll use that as a proxy for how the stock market performed on any given day. And then let's take a look at the weather data set. Now this is going to be one row per day as well. It'll have every single day from May 1st, 2022 to April 30th, 2023. And for each of those days, it'll have the average temperature for that day in Fahrenheit, precipitation in inches, snow in inches, and the average wind speed for that day as well in miles per hour. Now, this is the weather for New York City in particular. The idea is there's a lot of trading that happens there. It's where the New York Stock Exchange is, for instance, that a lot of companies are listed on. We could do our analysis on maybe nationwide weather by trying to average weather, but in this case, we feel like New York City is really relevant. So we're going to see if there's a relationship between New York City weather and the S&P 500 as represented by this SPY index. Now, both of these data sets were created in Python by pulling from one, a stock API, and two, a weather API. And I actually have the code for that in the Jupyter Notebook that we're about to take a look at. And if you wanted to update this to look at weather from a different city or look at another specific stock price for a particular company, you'll have the option you can do that within the code and update it. If you wanted to change the time period that we're looking at, you could also do that within the code. But those are the two data sets that we're going to be looking at. Both of them are essentially one row per day. Again, stock data set only includes days that the stock market was open. And we're ultimately going to use SQL to bring these tables together to do some analysis on the relationship between weather and stock performance. You can find a certain amount of information and a certain amount of insights from one data set, but so often you find the real meaningful insights when you bring data sets together. And that's exactly what we're going to do next. Well, now hopefully you've got Anaconda installed on your computer. You've downloaded the files that we needed from valuedrivenanalytics.com for our analysis, and we've even taken a look at them in Excel. So now it's time to launch Jupyter and run some SQL code within Python. So in order to do that, start with your magnifying glass if you're on a Windows computer and search for Jupyter here. I'll click on Jupyter Notebook. It'll launch a little black command line here. You want to leave that open for the length of the entire Jupyter session. It's a Python related thing that we covered in our Python training session. And again, if you want to check that out, the link is in the description. But here we are. It kind of mirrors our Windows Explorer environment. I'm going to navigate to where I saved those files. So wherever you save the 2 Excel files that we downloaded from valuedrivenanalytics.com, that's where you want to navigate now. Let's see here. All right, so you'll see here we've got our stocks file and our weather file. So save those in a particular folder for the SQL training session. I'd recommend creating a folder dedicated to that, saving those files there, and putting the Jupyter Notebook that you downloaded as well in that same folder. And we'll just click on that to open it. Again, this is all Jupyter Python related so far, not specific to SQL, but this is the environment where we'll be running our SQL code. So now you should see this Jupyter Notebook that we've got opened up here. And the first thing that we'll do is run this first code cell. So in order to run a code cell in Jupyter, you have to click into the code cell, and you can either click run after that or use the keyboard shortcut, which is shift enter. Hit shift, hit enter, and then let go of both. I'll do it that way here. And it goes ahead and it runs that. Now before you run that, update the path here to the path of whatever folder that you saved your 2 files in. So in my case, I've saved it in this file, and so I'm just putting the whole path to that particular folder right here. And no slash at the end here, just this, it should end in the name of the folder, not the file, but the name of the folder where all those files were saved. So go ahead and update that and then run it. You can run it again with shift enter. All right. Then next, I'll just kind of walk you through how those files were actually generated. You've got the code right here. The first code cell block is how I created the weather.xlsx file. It's using the Meteostat package, and just follow the notes here. There's a lot of comments here to walk you through how to do that. You'll see I'm downloading it for May 1st, 2022 through April 30th, 2023, but here's a way that you can make that dynamic based on the last 365 days whenever it's ran if you wanted to. Pulling the date, the temperature, precipitation, snow, and wind speed, and converting it to imperial units as well with this step. So we ultimately get that from the API. I saved it to an Excel file, put it on the website, and that's where you download it from. So the next step here is to then create the stock data set. Now you don't need to run these. If you've downloaded them from the website, you've already got them. I'm just showing you how you could, how I went about pulling the data. And if you wanted to pull this for a different time period or a different city, you can. Note that I'm doing this for New York City. And for stocks, I've mentioned the SPY index, which is a proxy for the S&P 500 companies, how they're doing over time. And so I downloaded the stock data using this Yahoo Finance API, and just getting the date, the open price, the close price. And the previous close I'm getting by taking the close price and shifting it by 1, which essentially creates a lag variable of the previous close. We saw that in Excel. And then ultimately we take those files and we save it to an Excel. We take that data that we pulled from the Yahoo Finance API and we save it to Excel. Again, this section, nothing to do with SQL. It's Python related. If you've watched the Python videos, maybe some of this resonates with you and you might be able to run and update it on your own. But I just wanted to walk you through how those files got created. What we're going to do is start right here, right under where it says start running code again in cells below. And we're just going to start by importing the data into a Pandas data frame. Again, Python code so far as well. The file folder here is referencing the same file folder that you set up here, so make sure this is where those files are located, and then this code should run just fine. So at this point, the files have been brought in to Python, and we can access them as Pandas data frames. Let's just take a quick look at what our Pandas data frames look like within Python, but they should look exactly the same as when we looked at them in Excel just now. Here's weather. So in Python, you can just type the name of any object, including a Pandas data frame like this is, and there's the first 5 rows. Our weather data set starting in May, last 5 rows ending in April 2023, just like we saw in Excel. Do the same thing with stocks here. First 5 days the stock market was open since May 1st, 2022. Last 5 days it was open as of April 30th. Ended, last day was April 28th, wasn't open the 29th or the 30th, with the open close and the previous close, just like we looked at in Excel. Just a reminder there, we're looking at the same thing in Python. Now let's get into SQL. So for SQL, running SQL in Python, again, we're going to use this pandasql package. It's a package specifically devoted to running SQL on Pandas data frames. Now, some of the packages we've used so far, such as Pandas, I think there's been a few others, not necessarily the ones that we use to import to actually create the data, like MediaStat and YFinance. Those are ones that are in a similar bucket to PandasQL, where they're not the most popular packages, and so they weren't necessarily imported when you downloaded Anaconda, which means you'll need to, say, installed when you installed Anaconda. And so you will need to install these packages one time. You only need to do this one time, and you shouldn't have to do it ever again for as long as you're using that Python instance. And so in order to install a package, it only needs to be one time ever, essentially. What you would do is go to the command line with an exclamation point. I've got the code right here, actually. You could just copy this. But exclamation point tells Jupyter that we're in now, the interface we're in, the IDE we're in. It tells it to go to the command line and run the following command. And in this case, we're going to pip, which is a repository, Python packages. We're going to ask it to install something. And then what comes after that, and all these separated by spaces, is a package name. And in this case, we want to install the pandasql package. So if you were trying to run the code above, for instance, MediaStat, instead of pandasql, you'd be putting MediaStat there. All right, then you'll just run that. Click into the cell, click run, or shift enter. We'll do the job, give us an update here. We're going to be using this throughout the rest of our Jupyter Notebook, because the focus here is really on SQL, less so on Python. Python's just the vehicle we're using to run SQL. We could have used SAS, we could have used R, we could have used Power BI or Tableau or any of those SQL databases we talked about, Microsoft SQL Server, Snowflake, Oracle, Teradata, HiveQL, all kinds of SQL platforms out there. We're using Python in this example. All right, in this case, I already had it downloaded, so it just says requirement already satisfied, but it should say installation completed successfully. And if you get a different message, feel free to leave a comment, and I'll try to help you troubleshoot. But I'm going to highlight this now, and in order to cut a cell, you can just click the scissors, plus to add a code cell, and then scissors to remove it. So in Python, what we need to do in order to really use pandasql package to run SQL code is we're going to reference pandasql, and we're going to reference the SQLdf function within pandasql. Consistently going to reference that. And like a lot of functions and a lot of platforms, after that comes an open parentheses and then your arguments. And our argument in this case is just a set of text, the text for the SQL query. Triple quotes are good in Python. This is still a Python. This whole line is a Python specific thing. Triple quotes are good because if it runs into any single quotes or double quotes within your SQL query, it'll ignore them. It'll only stop the text when it sees triple quotes again. So I've set that up here. Globals, another thing I've added here, and then close parentheses to close off the function. And this df equal sign means that whatever the result of this SQL query is, the resulting table from that SQL query would be put into an object, a pandas data frame object called df. So when we want to reference it later, like when we want to display it right here, we would refer to it as df. That's the results of our SQL query in this case. All that's Python setup. And so the only thing, the real thing when we get into SQL, for every single line from here on out is going to be what is inside that set of triple quotes. This is the SQL code. Everything around it is Python within the triple quotes. These three quotes, these three quotes. Notice when we go to the next line here, same thing, three quotes, everything inside. In fact, it's highlighted red right here, or orange. That is SQL code. So let's take a look at this first one. This is one of the most basic SQL queries we can write. Almost every SQL query is going to have a select statement. And just about every select statement, every SQL query will have a from statement as well. Doesn't necessarily have to. You can pull like the current timestamp without referring to a table, but almost always your query will have a select and a from statement. Now what we'll see is we can select specific columns, but the keyword star within the select statement, so select, and I could do this, I could have a space between select, I need to have at least a space between select and star or my columns, or I could just put it on the next line. Either a new line or a space will separate those those words, and it's saying select. What do you want me to select? Star. Star is a keyword in SQL, or a key symbol in SQL that indicates I want you to select all the columns. Star means all the columns. It's a shortcut. So instead of having to select and list out all 5 of these columns, if we want, we can just put a star there and it selects all the columns in the table. And then from is another SQL keyword, and it tells us, I'm about to tell you which table to pull from. Now, in some cases, if you're pulling from a database, maybe a SQL Server database, sometimes you'll have a certain database that it's saved in, could be called DB, for instance, and then you'd separate that with a dot. And then within a database, you could have a schema, which is kind of like a folder within a database of tables, and maybe it's schema 1. And then you have another dot, and then after that would be the name of the table you're pulling from. So that's how you'd be pulling it if you're maybe pulling directly from a database. In this case, we're just running a SQL query against the Pandas data frame. And so all we do in here is refer to the Pandas data frame that we're pulling from. And notice up here, we gave the weather file, we named it weather, very appropriate. And when we imported the stocks.xlsx file, we called that stocks. So within our pandasql SQL query here, we're just going to refer to it as the name of the Pandas data frame. There's no need in this case to list a database or a schema name. So we'll say from, and then we'll list the name of the table. Simple as that. This will run. Let's see what the results are. So this SQL query, select star from weather, runs. It gets put into a Pandas data frame, which is basically a table in Python, called df, and we're displaying that. And what you'll see here is it's all the rows. It's 365 rows, May 1st through April 30th, all the columns. All the columns because we said select star, and all the rows because we haven't put a where statement in yet. And we'll show you what that does. But if we wanted to subset those rows and only include certain rows, we would use a where statement. This one doesn't have a where statement, so it selects everything from the table. This query right here is enough to be very powerful for you. In fact, if you didn't want to learn any more SQL and you had access to your database and you just wanted to be able to get data from the database so then you could bring it into an Excel or another platform, maybe Power BI or Tableau even, you just needed a way to get it out of the database, this will work for you. Select star, and then if you list whatever table it is, it's going to get you all the rows, all the columns. Now, SQL is very powerful. I highly recommend continuing to learn about some of these other techniques that we can, so you don't have to bring in all the data if it's not needed. If you only need certain columns and only certain rows, if you're building a Power BI dashboard or Tableau dashboard or doing Excel analysis, you only want to pull the data you need. Otherwise, it'll slow down your analysis or your dashboard. But this alone is very powerful for just getting all the data from a particular table. That's our first SQL statement there. Now next, I'm going to show you how you could pull just the columns you need perhaps. And so instead of, the only thing that's different here is now we're selecting specific columns, 3 of the columns. Average temperature, precipitation, we're not going to be pulling snow or wind speed, just the date temperature, and precipitation. And you can see the way we do that is instead of selecting star, we select the specific column names. Notice they're separated by commas here, except for the last one. The last column that you select should not have a comma after it. It'll error out if you do that. There needs to be no comma after the last thing you select. But all the other columns that you're in your select statement, like between date and temperature and precipitation, need to have a comma between them. And then after this precipitation is our last column, and then comes the from statement, same from weather that we had before, telling it which table to pull these columns from. No comma between those, or else you'll get an error. Another thing to pay attention to here, if you have a variable that just has one word and no spaces, or maybe it does have multiple words, but they're all put together, they don't have a space between them, for instance. Sometimes people will use capitalization to denote the difference in words. Sometimes people would use an underscore. If it's all one word, doesn't have any spaces or special characters, like question marks or periods, then you don't necessarily need a double quote around it. For instance, date, I could probably get away with just that. Average temperature, though, here does have spaces. I like spaces personally in my column names because it's already written in a way that I could present in a dashboard or in Excel. I don't like to send out Excel files or dashboards or anything really that has a bunch of underscores in it. It just doesn't look as clean. So I like using spaces myself, but if I'm going to do that, I need to make sure I put quotes around the variable, double quotes in particular, and that'll let SQL, Python in this case, know that that's one variable that I'm selecting there. So if your variable name does have spaces in it, like temperature and precipitation in this case, then you want to put double quotes around it. And you could go ahead and run that again, clicking into the code cell here and click Shift Enter. What we'll see is we're only selecting the 3 columns. Same number of rows, 365 rows like we had before. We haven't done anything to change the number of rows. We're still selecting from the weather table, same table, no where statement. It's going to select all the rows, but we've specifically called out which columns we want to pull instead of selecting star, which indicates we want all 5 of the columns, all the columns in the table. All right. Well, let me show you how to rename these columns. Maybe this initial column was a little bit long, Fahrenheit. Maybe we think that's self-explanatory and we just want to call it average temperature. Same thing with precipitation. We want to shorten it a little bit. That's where an alias comes in. And in this case, alias is just renaming something. So what we use for that is an as keyword. So same, select 3 columns from the weather table. The only thing that's changed here is before we get to the comma that separates the variables, we select that variable, do a space, and we use the keyword as, and then we put another space after that, and then we give it our name. Now, again, it's the same principle as referring to the variables. If I was doing something that didn't have any spaces or special characters, I don't need those double quotes here. But if I want to name it something clean that has a space in it, then I can use double quotes to handle that. I need to use double quotes, and it doesn't hurt to use double quotes here, like in precipitation here. This will run just fine, even though I don't really need the double quotes for precipitation because it doesn't have a space or special character in it. So now if I run this, notice how I'm pulling the same column, same number of rows. My data within the table isn't really changing, but the names are different now. That's what the as does. And I would recommend including the as. It's a lot cleaner that way, but technically the as isn't even necessary. It kind of knows that, hey, if I'm selecting something and then you see a space and then the name's there as well, that's a rename. But it's a lot cleaner. I would recommend including the as. It makes it really clear what you're trying to do here. Well, before we get into our where statement and filtering the data down, let's actually order the data. This would be the equivalent of using the order by function in Excel. And in Excel, you can order your data by multiple things. Same thing in Python. And if we could order this using Pandas syntax as well, especially since we're in Python here. But we're going to do this with SQL syntax, and that's just adding an order by statement. Now we're starting to get multiple keywords in here. We've got a select statement here, and then followed by all the names of the columns we're pulling, followed by a from keyword, followed by the table we're pulling from. That's a SQL keyword. Another SQL query that keyword were just introduced is the order by statement. This order matters. Your select statement always needs to be before your from statement. And if you have an order by statement, as you could see before, we didn't have an order by statement and the SQL query ran just fine. It just had the default order that the table was in. But here we're explicitly ordering our table in a certain order. If we're going to have an order by statement, it comes after the from statement. So far with the parts of the SQL query we've looked at, your select statement would come first, then your from statement, then your order by statement. And this works similar to Excel where you can sort by multiple variables within other variables. So the first thing we list is the primary thing it's sorting by. First and foremost, it's going to sort by precipitation, the precipitation column. And it's going to sort by that in descending order because we've put DESC, shortcut for descending here. I could put ASC for ascending here, but really the default is ascending. So if I want it to be in ascending order, I just wouldn't put anything there. But if you want it to be in descending order, you have to call that out since ascending is the order. So by default, it's going to sort our table in descending precipitation order. And sure enough, first row here is where precipitation was 2.8 inches and then 1.6 and 1.5. We can see it's counting down. It's sorted our rows descending order on the precipitation column. But then within that, notice here's some ties right here where they had 0 precipitation. Within that, we've passed another thing for it to sort by, and that's average temperature. Doesn't have descending following it, so the default gets applied, which is ascending order. And what you'll notice is the temperature is going up. It's in ascending order among the rows that have the same precipitation value, in this case 0. That's how sorting works in SQL. And finally, we're ready to actually filter down the rows that we pull back. We've filtered it down to just certain columns by including those specific columns in our select statement. Again, instead of star that selects all of them. And we've got our order by statement from before. I've simplified it here. I've added ASC, but you really don't have to have that because it's the default. But I've also added a new statement here, and that's the where statement. And as you'll notice, and this is very important, the where statement, if it exists, it doesn't have to exist. So far, we haven't used a where statement. We've pulled back all the rows. It goes between the from statement from the table and the order by statement if the order by statement is present. It needs to go between those two. And so in this case, a where statement, it always filters down rows. And in this case, we're referencing the temperature variable, and we're trying to pull rows only where the average temperature is less than 20. We could have done greater than. We could have done exactly equal to with an equal sign. Greater than would have worked. Greater than or equal to could work like that. But we'll stick with the less than 20 for now and run that. And you can see the only rows it brings back are rows where the average temperature was less than 20. Very easy. Just a where statement. Where, and then you list a variable, and you could say equals or less than or greater than. Quite a few options, and we're going to see a few here as we move on to our next coding cell. Maybe there's multiple criteria that need to be applied, either or criteria or and criteria. There's a lot of things that need to be considered when determining whether to keep that row. This is something SQL makes really flexible. Here's a case where we only want to see rows where the temperature is less than 50 degrees and the precipitation is greater than 1 inch and the wind speed is greater than 10 miles per hour. So maybe right now we're trying to figure out what does a bad day look like for New York City. If we were to use these parameters for those columns and look for days where all 3 of those things were true because we have and separating the conditions, how many days would that actually be? Well, we can run this. There's only 1 day. And as you can see, less than 50 degrees, check. Precipitation greater than 1 inch, check. Average wind speed greater than 10, check. All right, so that's an example of and criteria. What if we just wanted to check if either one of those were true? We could replace this and with an or. We don't have to have 3. We could have just 2 conditions like this, or we could have even more if we had more conditions that we wanted to check. Well, now we're going to get 102 rows. And notice, well, wait a minute. Here's a day that's less than 50 degrees, that's more than 50 degrees. How did it pass? Well, It didn't meet it because of the less than 50, but it's an or statement. And so this was a day where, well, it looks like the precipitation wasn't too bad. But the wind speed was greater than 10. And so it looks like all of these rows, it looks like a lot of the rows here were included because of the wind speed. Their wind speed was greater than 10. So if we increase this threshold to something like greater than 20, okay, they're obviously not being included because of the wind speed, but it's an or statement. So in this case, it's included because the temperature is less than 50 degrees. Well, here's one where the temperature is more than 50 degrees, but the precipitation is greater than 1. And so that's why it's included. You get the idea. That's the or statement. Now, anytime you use a combination of or and statements in your SQL query, you need to use parentheses. You would not want to, for instance, do something like this. And maybe you're thinking, well, I want to pull days where the temperature is cold, it's less than 50 degrees, and either the precipitation is greater than 1 or the wind speed is greater than 20. If either one of those are true and the temperature is cold, then I want to pull back those rows. This is not the way to do it. This will confuse SQL. You won't get the intended results. In that situation, you need to use parentheses. You're saying, I only want a row if it's less than 50 degrees, but I also only want among those less than 50 degree day rows conditions where it either rained a little bit or had high wind. So in that case, you would put parentheses around the or statement here. That's really important anytime you have a combination of and ors. Let me do that here. Okay, so we can see all of these meet the first criteria because it's less than 50 degrees. And then we get this day that's included because of its precipitation, and these days that are included because of the wind. We didn't have any that had all three in this case. So be sure to use parentheses whenever you have a combination of and or statements in your where statement. See how flexible it is here. If you can dream your where statement, you could probably implement it with SQL. Now, another thing that can be convenient in where statements is maybe you have a case where you want to filter on multiple values within a certain column. Now, you may have a situation where you have one column you want to filter down on, but you want to filter and include multiple values within that column. So one way of writing that, let me comment out here our final solution that we'll use. But in the meantime, I'm going to do a /* at the beginning and a */ at the end. This is a way of commenting out code in SQL, starting, and this can actually span multiple lines. If we had this across multiple lines, this would still work to comment out the whole section. Essentially, wherever there's a / begins our comment out, and then whenever you get to a */ again, it says, all right, that's the end of the comment, start running code again, if there's anything after that. So I'm commenting that out. Let's say we wanted to filter on our date variable in this case. Now, most of the time, within most SQL platforms, you'd simply be able to refer to the column date in this case, and you wouldn't even have to have quotes around it because, again, it doesn't have a space within the name of that column. But I'll say where date is in, and then I would list dates, and most of the time in most SQL platforms, so if the date equals 20, 22, 12, 24. Now we could actually use a greater than sign if we wanted to. Get anything greater than this date or greater than or equal to that date would work as well. But we'll say, greater than or equal would be that. We'll say equals in this case. And if we're just using what we've talked about so far, then we would have to say something like or, and then list out date again and say equals 2022, 1225. And then we might even say, do that again, right? And say, or the 26 in this case, if we wanted to filter on either one of these values, we're okay including it. Otherwise, we don't want to include it. Something like this is how we would have to write it. Now, here, this is something specific to SQLite 3, the version of SQL we're using for Python. It requires us to put the word date around our date variable and the values that we're filtering on to say that this is a date variable, this is a date value. You have to put that around all of these. And that's just the again, the version of SQL, SQLite 3 requires this. Most versions of SQL, if you were using SQL Server Management Studio or Snowflake, this would not be required. You could just refer to it as we had so far. Run this. Hey, it returns the 3 days we're looking for. Great. But that was a lot of writing. We had to list our date column over and over again, even though we were just looking for a different value each time. That's where the end statement comes in. So instead of doing it that way, where we have to write it all those or statements, we can simply use the date column, that's the consistent part across all three of these, and we'll say in, and then it's open parentheses, and we'll list all the values that we would want to include and separate it, just simply separate each one of those values with a comma. Okay, so these three date values separated by a comma, and then we have to close our parentheses. Anytime you have open parentheses, you've got to close it with another closed parentheses. So this is a little shorter. We only had to list the name of the variable once, and then use the keyword in, and then listed a list of values separated by commas that we were okay including rows for if it met that criteria. And this returns the same thing, but it's much briefer. So I wanted to show you that. Another technique you can use if you wanted to say, well, I want everything that doesn't equal those, you can use not in. You just type the word not in front of it. And there you go. You just get all the other rows here. Another approach too, especially if you have multiple criteria, you can always, again, use parentheses around criteria, and there could be multiple here. In this case, we only have one criteria, but you can put parentheses around this whole thing. So in this case, it would just return those three rows. And another approach, where statement's really flexible, just put not in front of that parentheses, and that works too. It's the same as doing, in this case, that variable is not in that, or you can just put parentheses around this, especially if you had another criteria, maybe within the parentheses, like, or, temperature less than 40, something like that, and you wanted to grab all the rows that do not meet this or criteria, putting not around the parentheses is a great way to do that. All that to say, where statements are very flexible. All right. Let's move on to the next thing we're going to look at, the between statement, another way of enhancing your where statement, and this will be able to be used to create variables as well. The between statement is efficient, especially if you have quite a few variables and they're all in the same range. In this case, we want to say all the dates, same thing, between December 24th, 2022 and December 26th, 2022. In this case, we had to list out all three of those values, right? And it could be an even longer span, which would mean you have to list out even more dates. Well, if it's all in the same range, using the between option is a great option. And you could use this for numeric variables as well. Between 5 and 10, for instance, if you had a number variable. In this case, we're applying it to a date. So you run this with the between, and there you go. We get the dates that are between the 24th and the 26th in this case. Perfect. We would have done this for November, pulls an even longer range. All right. Another important concept in SQL and a lot of platforms, a lot of coding platforms, especially when it's applied to analytics, is the concept of null values. Sometimes you've got missing data, and missing data is different from a zero. For instance, in some cases, if you had a zero, that would mean there was 0 for snow, for instance. That would mean there's 0 snow. There did not snow that day, and you know it. It was recorded. In other days, snow might be missing, which means we don't know whether it snowed or not. It's not necessarily a 0. So there's this concept of missing data. It's just a fact of life. Sometimes some columns are populated for a certain row and others are not. And so you need to know how to handle missing values. And one way of starting is at least to know whether there's any missing values. And so this is a way to check whether, for instance, the snow field is null or not. It's going to pull back any rows that are null. And when you refer to a null value, it's not as simple as, you might think it's just equal to null. Nulls are special. They have to be referred to in a kind of a special way. So the way to pull back null rows for a particular variable, in this case snow, would be is null. And there aren't any in this case, which is nice. Kind of prefer to not have missing data. And then if you wanted to just pull back cases where it wasn't null, you do is not null. And it's all the rows because there weren't any null values for snow. And you can always, again, another way of doing that is just to use the not and then the parentheses around the whole statement. That's another way to say anything that doesn't meet this criteria, pull back. You can always use that. All right, well, let's talk about functions. So now we're kind of moving a little bit more back to the select statement, but these functions could also be applied directly in the where statement. You can nest these functions, and a lot of the things we've talked about, you can nest them together. There's a lot of functions in SQL, and some of these functions, especially the date ones, the one we're about to look at here, can be slightly different in one SQL platform versus another. This is something that can be different. A lot of the concepts like the select statement, selecting variables separated by commas, the from statement, the where statement, the between statement, order by, all of that tends to be basically the same across all the SQL platforms. But some of the function related things, especially date functions, can be different depending on whether you're in SQL Server or Teradata or SQLite 3 in Python like we are now. So the first thing we're going to do, this is SQLite syntax. Now here we're going to look at how to pull parts of dates out of a date variable, specifically in SQLite 3. Now, if you're curious and you want to find more information about how to do other kinds of date manipulations within SQLite 3, if you scroll up around the part, right where we start our first SQL query here, I've got this path here, and you can use this to look up different date manipulations for SQLite 3 specifically. But we're going to look at one in particular. Scroll back to where we were. And that is extracting the year. So you can see it uses this strf time, open parentheses, pulling out %y, which is the way to refer to the year for SQLite 3, from the date field. And we're going to give that a name. Really important when you're applying a function to something to give it a name, because otherwise it's just going to make up a name. So we have the as statement here, and then we're going to call that year. Similar here, just selecting the variable itself. In this case, we're not modifying it at all other than renaming it with the as statement like we saw before. But you can also apply math to that. In this case, we're just taking that variable, dividing it by 2, and we're going to get that variable divided by 2. You can see that right here. This is just this temperature divided by 2. And also with year, you can see it took the year out of this date. Another one here, we're selecting precipitation, unadjusted other than just renaming it with the as statement. Also selecting snow, unadjusted except for renaming it with the as statement. Here we're actually going to add the two, take precipitation plus snow. And so in this case, let's see if we have any snow cases where we can prove that out. Not very interesting here because snow is always 0. Although if we wanted to apply a quick where statement, we could say where snow is greater than 0. Maybe that'll be a little more interesting. One thing, if you did have null values, the way we're using it here really applies to null values. You can use the function coalesce. This is so helpful. If for some reason snow did have some null values, they were missing altogether. They weren't 0, they were missing. Whatever happens, whenever this variable mentioned here is null, it'll move on and use the second argument in the coalesce function. In this case, it's not a variable at all. You could list a variable and say, okay, when snow is null, use this instead. In this case, it says if it's null, use 0, impute 0, which may or may not be a good solution for every variable. But that's a really useful thing about coalesce. Use the first variable, the first argument, if it exists, but if not, move on and use the second thing instead. Could be a variable, could be a constant value like 0 in this case. And you can even nest those. So we're taking that coalesce and we're adding it to precipitation in this case. Doesn't make a difference because snow is not actually null in any of the rows, as we saw in this case. But those are just a few functions that you could apply, and there's so many others for all kinds of data manipulations using SQL. This is just a sampling of those. Really neat thing you can do in your, well, again, you could use this nest that what we're about to show in your where statement as well, but a case when statement is so helpful. It's the equivalent of an if statement in Excel. And when you have multiple conditions with an if statement, you've got to nest them if you have multiple conditions. And it can really get messy quickly if you have a lot of conditions to check. I think case when statements in SQL do this better than if statements in Excel personally. What we're doing here is we're going to define a variable, and it's going to be an indicator of whether there's bad weather. And as you can see here, there's a few criteria. If the temperature is less than 40 degrees, if precipitation is greater than 1 inch, or if the wind speed is greater than 20 miles per hour, we're going to say that's a 1. That means it's bad weather. Otherwise, it'll be a 0. It's not bad weather. 1, 0 variables, binary indicator variables, very common in analytics and data manipulation and data analysis. It's very convenient to work with those in a lot of ways. So that's what we're creating here. And there's what you'll notice is with a case when statement, it always starts with the word case. That's telling SQL I'm about to create a variable via a case when statement. Then you'd have a condition that would start with when. So when is saying, and I'm about to give you a condition. Then you list the condition. This could be multiple conditions. It could say, and this is true, or this is true. So it could be a set of things, and you could use parentheses around it if you had ands and ors being used at the same time, just like what we talked about with the where statement a bit ago. But ultimately, after you list that condition, you would say, here's what I want this new variable to equal, what the value to be, if that condition is true. I want it to be a 1. Now, if that condition is true, it's going to assign that value, and it will not look at the rest of the rows for that row at all. It skips, so it says, okay, it's met this criteria, I'm stopping here. But if that condition was not true, it'll move on to the next one statement, if there is one. And say, okay, well, is the precipitation greater than 1 inch in this case? And then we could assign a different value here if we wanted to. In this case, we want them all to have the same value. But if we needed to, we would say, okay, what do you want it to be if that's the case? So notice in this situation, if I set this rain is greater than 1 to be a value of 2, if the temperature was 35 degrees, and it was, so it meets this criteria being less than 40, it stops here and it gets a value of 1. It does not move on to this. Even if the precipitation is greater than 1 inch, it never gets to this point. So it's going to have a value of 1, even if this condition is true, because it stops whenever a condition is met in the case when statement. But if neither one of these are true, then it would move on to check and see if the average wind speed is greater than 20. If it is, it'll assign a 1. And then at the end, we have an else statement here, which means if you have gone through all the when statements so far, however many you set, we could have just had 2, for instance. If in none of those conditions were met, here's the value it assign, in this case 0. Now, if you don't have an else statement, and there's some cases where none of the previous criteria were met, the result would be null. That would generate a missing value. But if you have an else statement, it catches all of those, and in this case would assign a 0. Could assign whatever value you gave to it. All right, so we'll undo some of these things. Now, I also want to note that this is creating a numeric variable. The result is always a number, and there's no quotes around numbers, as you can tell. We could also create string variables or character variables. There's all kinds of variable types in SQL. Character variables, varchars, just pure numeric variables, float variables. There's all kinds of date variables as well. We've seen an example of that, or date variable column that's actually called date. But if we wanted this to be, maybe we just call it bad weather, we can use, and I use single quotes for this. We use double quotes to refer to variables like we did here. We use single quotes to refer to values within those variables. That can be important depending on the SQL version you're using. So we might say then bad weather, but if we're using a character, we can't just get away without any kind of quotes. We need to put that value in quotes. And we would need to be consistent too. If we try to assign a 0 here, when we've been assigning quotes here, that's not going to work. That's like a mixed data type. And so we would, in this case, we'll just do, our one. But I wanted to point that out, that you can have character variables and you can have numeric variables. So this is going to be a numeric variable. Now, the last thing that tells your case when statement that you're done defining the variable is an end statement. And we just use the keyword end, and then it's very important to give it a name so that SQL doesn't just assign something. And so we're calling it bad weather. So this is a case when statement. What I like about this is you've got multiple when statements here, multiple conditions and multiple values, but you don't really have to nest anything. It's just separate when statements versus in Excel, you've got all these multiple criterias, if statements, and you've kind of got to nest all of those. So that's a way to create bad weather. Now, I want to show that this could also have been probably even more efficiently written in this case, because all of these conditions result in a 1. When that's the case, you really don't need to write it this way. We could have just said case when, and then temperatures less than 40, or precipitation greater than 1, or wind speed is greater than 20. It's basically all the same condition. So it's basically all on one line, then 1, else 0. That would be an equivalent way to write this, an even more efficient way to write this. But I wanted to show you how you can have multiple when statements, and you would need to write it this way if we were going to assign a different value for each one of those conditions, for instance. All right, so we do that. Yep, we've got a couple of examples here where it was considered bad weather. It wasn't because of snow, or sorry, wind speed. It wasn't because of wind speed. The wind speed is less than 20. It wasn't because of temperature. Temperature was greater than 40 degrees. It was because there was precipitation that day. So it was a 1. And it looks like all of these, none of these have bad weather indicators, so these are all zeros. Just doing a little bit of checking to make sure it meets expectations. Now, the distinct keyword in SQL is really powerful. By default, if we were to just run a simple SQL statement like this, it would just pull back the snow column, and it would pull it back for all rows, all 365 rows here. But what happens is if we put distinct at the beginning of our select statement, it'll pull back only the distinct values of that column. In this case, there's only 3 distinct values. There's a lot of rows with 0, and then these 2 others as well. So it's deduping it and just telling us, again, the unique values within that column. Now, what we could do here is add another variable. This would be good to show what happens when you have a couple of variables in, and you can have 3, 4. It's ultimately going to select the distinct combinations. So if we put average temperature in there, we're going to get even more combinations. Now it's every unique combination of snow and temperature. And you can see there's a lot more of those. So whenever you use distinct, it'll be the distinct combinations of all the variable values within the variables that are listed after that, in this case, snow and temperature. If there were 2 values, for instance, that had snow of 0 and average temperature of 56.8, they would get deduped and just have one resulting row. But if there's obviously here multiple rows with 0, but the temperature is different, that's a different combination of the variables in the select statement, and so they result in different rows. Now let's do some aggregation, and this is one of the things that SQL does really well. Basically, we've got 365 rows, and we might want to get some summary statistics for them, for instance, at a high level. Boil our data set down to maybe just 1 row. We might want to know the total number of rows. To do that, we can use the count function. And we'll do count, and we'll use that star again. In this case, star is being used to say count every single row. So we're just saying count star, total number of rows. We can count date, and the thing that's different about this, that can be different, is count against a specific column, like date in this case, only counts non-null values. Null values for any rows, it will not count those, which can be helpful. We'll talk about some ways that could be useful to you, but that's very important to note that when you count a column, it only counts non-null values. Counting snow here as well. You can use the min function on a date variable or a numeric variable. You can even use it on a character variable, and it'll take the first value alphabetically. Same thing with max. So both of those are options. We'll take both of those, and you can see there's 365 rows. There were no null values for date or snow, and so they also have a count of 365. But if they did have null values, these would potentially be lower than that because they wouldn't be counting those. And then date, May 1st, 2022, max date, April 30th, 2023, all like we expect. We can take the minimum temperature, average temperature is a good one. And the max temperature, we can sum precipitation across all the days here. There's quite a few aggregation functions. And what you'll notice is it's just returning one row. It returns the result of that particular aggregation function across the entire data set. It's really helpful for analysis. Where the count can really come in, the fact that count only considers non-null values, well, count star is going to count every single row, regardless of whether a column has null values or not. It's not even referring to a specific column. It's truly going to tell you how many rows are in that table. And it's really important, especially when we start joining tables together, to know what one row represents in your data set. In this case, these are one row per date. But if we wanted to check that, and that's kind of what we're doing here, we can count the date field and we'll get all the non-null values. So that'll tell us whether there's any null values here. But if we really wanted to know whether it was one row per date, for instance, whatever we think it's one row per, we can do what we're doing in this next cell, which is to count star, same thing we did before to get the total number of rows, but now count distinct, whatever we think it's one row per, in this case date. And if those two things are the same, that means your table truly is one row per date. It does not have any rows for a particular date that are in there multiple times. You'll never find a particular date across multiple rows. It is one row per date. And that's really important when you're joining tables together on date, for instance, because if that's not true, you could end up with some unintentional duplicates. So always know what one row represents in your data set. And this is a great way to find that out. If these are the same, count star and count distinct on whatever field you think is the unique identifier, great, you're good. No duplicates. Feel free to join it on that value to another table perhaps. But if you were to find that perhaps count distinct date was a value of 300, well, there's 365 rows. That must mean that there's some dates that have multiple rows. Well, we've done some aggregation here, and we can get everything boiled down to one row. Sometimes we want to aggregate, but we don't necessarily want it boiled down to one row. We want to group within a certain variable. I'd like to see all the rows that have this value within this variable, and I want to see what the average temperature is, for instance. Maybe we want to look at average temperature by month or something like that. Well, in this case, what we're going to do is group by month. And so the way to do that is we're first going to build a month variable, and we're kind of nesting functions in this case. We're using this SQLite 3 specific function of the strf time. We're extracting the year like we did before. So this is going to pull out the year part of the date. We're going to multiply that by 100, and that's going to allow us to add then the month. And month, it's using the same function here, strf time, but now we're pointing to percentage %m, which will pull back the specific month part of that date, and we're adding that. So you can see what happens over here. The month ends up being in the first two digits, and because we've taken the year and multiplied it by 100, that ends up being the first four digits versus the last two digits representing the month. So just kind of a quick way to create a month variable here. We're nesting those, we're bringing it together as this year month column. Notice what we've done here. We've created a group by statement as well. We haven't seen that yet. Whatever we select that's not being aggregated needs to be in a group by statement. In this case, we're kind of saying compress everything across values within this column. In this case, it's a kind of a calculated column that we're creating on the fly here in our SQL query, this year times 100 plus month. And we're also ordering by that variable as well, as you can see. So let's note the group by statement comes after the from statement. If we had a where statement, which we don't in this case, it would come after that where statement as well. You'd have your group by statement, and the order by statement comes after that. Very important to get that order right. So we'll just pretend like there's a where statement here. Select statement, always first. then your from statement, then your where statement, then your group by statement. There's something called a having by statement that we won't cover here. It's a kind of similar to a where statement, but at the aggregated level, that would go between the group by statement. Again, if you have a having statement, all these statements, where, group by, having, order by, they're optional, and then order by statement would come last. So note that order for sure. But what you'll notice after the year month here, and we could have grouped by multiple things if we wanted to maybe group by, let's see, year month, and let's say we had multiple cities in this data set, we could group by city as well. But notice we're not applying any kind of aggregation. We're not summing or counting or taking the min of city. And so if we're going to have city in our query and we have aggregation, and we're not going to aggregate city, we would need to include that in our group by statement as well. If we did that, we'd have another variable here that would be city, and it would have one row per month per city combination. So it could have multiple rows for the same month for each city in the data set during that month, if we were to go down that approach. But in this case, we're just selecting month, and then everything, and we're just grouping by month, and everything else we're pulling in our select statement here is aggregated. There's either a count or an average, sum maybe, min, or other things. Everything else here are variables that are being aggregated. Again, count and average in this case. So we're taking the count of dates in months. So it's telling us, yeah, how many dates are in each month. We're getting the average temperature, so we can see it was coldest in December, it looks like, for this particular time period. Scroll down and see if that changes at all. No, coldest in December, 36 degrees. You can see the average daily precipitation here. Looks like it was highest in October. We can see the highest snow. It looks like it snowed in February and March. And then average wind speed, pretty consistent overall across the different months. So that's a way of seeing these statistics, a lot of the same statistics that we calculated up here before we had a group by statement, but now we're seeing them grouped, split out by certain values of this column we created, year, month. And here's the trick. Before we didn't need a group by statement because we were just aggregating. That's okay. You don't need a group by statement if you're just aggregating. You're going to end up with one row that summarizes the entire data table like we did here. And then in other cases, you don't do any aggregation, and that's okay. That's what we've been doing all the way up until this point. We're filtering the data set down, we're creating new columns, but we're not applying any kind of aggregation in this statement. And so you don't need a group by statement. You're getting all the rows that meet your where statement. That's fine too. But it's when you get a combination of some variables that are not being aggregated. These are functions, but they're not aggregation functions. They're kind of at the row level. They're creating a new column essentially for year, month, but they're not being aggregated. There's no count or sum or max or min being applied to this. So you have columns like that were primarily how we were working until we got to talking about the aggregation functions. And then you also have in your same select statement some aggregation functions as well, like count and average in this case. When you have a combination of those in your SQL query, you need to have a group by statement, and you need to group by any of the variables. You need to list in your group by statement any of the variables that are not being aggregated. In this case, the variable that's not being aggregated, the one that doesn't have a count or sum or average in front of it, is this kind of calculated field here that creates year, month. And so we took the definition of that and we put it in our group by statement. And a lot of times you do want to order by whatever you group by, not always. So we could have said, and show us the months that are coldest, for instance. Let's rank these by how cold it was in ascending order, so we won't put anything after it. And we would see that December was the coldest, followed by January, followed by February, and so forth. So we could still order by anything here, but it's extremely important to group by any of the variables that are not being aggregated. If you have any variables some variables that are being aggregated, again, like these, and some variables that aren't being aggregated like this, you've got to group by the ones that aren't being aggregated. in this case year month. All right, that being said, we've covered a lot of SQL syntax so far, just to show you what it's like. Now we're starting to get into our actual analysis of trying to understand whether there's a relationship between weather and stock market performance. So first thing we're going to do is do a little bit of exploration. We're going to make sure we know what one row represents in our data set by counting star in our weather data set and counting distinct of date, which is what we think one row represents. We're going to do the same thing in our stock market data set. Notice now we're finally pulling from a different table other than weather here. We're pulling from our stocks table that we imported at the top of our code, and we're counting distinct date in that table as well. Let's look at the results. And I'm using some Python functionality here as well to display each of these data frames. You can kind of just see a few rows from each one. But notice there's 365 rows in our weather data set, 365 distinct dates, which means that it's one row per date. Great. And then our stock market data set, it was one row. It is also one row per date. There were 250 rows and 250 distinct dates. Now note, there are fewer dates in our stock market data set, and that's because it only includes days when the stock market was open. So it's important to note that. Now, one of the things that I've noted here as well, want to explore everything here, is we kind of looked into this definition of bad weather and just ended up, and you can play around with this, but said if the weather is less than 40 degrees or the precipitation is more than 1 inch, or on that day, the average wind speed was greater than 20 miles per hour, we're going to say that's a bad day. That's a 1. Otherwise, it'll be a 0, which will mean it's a good day. And what's one of the things that's neat when you define a binary indicator variable like that is you can simply take an average of it and see very quickly what percentage of days had bad weather in New York City. And in this case, it's 18%. Okay, good. If this were really low, like 1% of the days, I'd say that's not a whole lot of days to assess whether bad weather had an impact or not, right? Especially just within 1 year. But 18% of the days having bad weather, that's at least a sizable number of days. So it's good from that perspective. Now, whether that's severe enough is another question. We could maybe do some more analysis and look at this in some other ways to figure that out. I'm also looking at the average return here just to see. And so return would be the close of that day divided by the previous close. We could also look at it from an open perspective, but sometimes there can be a pretty big gap between what the close was from the prior day versus the open of the next day. Maybe it's a reflection of aftermarket trading. So we're going to calculate the return for a given day as the close of that day versus the previous day's close, and we'll be assessing that against that day's temperature or winds. Really, bad weather is the definition of temperature less than 40 degrees or precipitation less than 1 inch or wind speed more than 20 miles per hour. Just doing some data exploration right there. What we're going to need to do, as I mentioned before, when you bring tables together, that's often where you really find the interesting insights. So we need to bring these tables together. We've got our weather data set that tells us whether there's a bad weather day or not. But then we've got our stock market data set that tells us how the stock performed that day. We need to bring these together. So we've already figured out that they are indeed one row per day, which means we can join these together, which is great. Now, there are going to be fewer days in our stock data set than there are in our weather data set. And I think that's okay. We understand that. We're going to do an inner join here. So this is the new part where we're joining the tables together. And as you can see, a join statement comes right after the from statement. If there were a where statement, it would come after this. So that's kind of where a join statement needs to be. It needs to be after the from statement, but before the where statement if there is one. But you list the join type first, and there can be a inner join, which we're using here. This is only going to keep days that are in both data sets. So all of those days that are in the weather data set on weekends, perhaps when the stock market wasn't open, they're not going to be included in the output of this SQL query. They get wiped out whenever we do an inner join. And it's also important to note what we're joining on, and that's where the on statement comes in. So a join statement starts with the type of join you're doing, and we're going to talk about some other join types here. The keyword join, consistently, whenever you're doing a join, there'll be join, the keyword will be in there. The name of the data set, sometimes this would be database name, .schema, .table. In our case with pandasql, it's just the name of a pandas data frame. Weather in this case. We're starting with, now our from statement is the stocks data set, and we're going to join to it the weather table. Notice there's some letters after this. This could also be written similar to our select statement, and alias is there. This is an alias. It could also be written as S and as W. Some might say that's the right way to do it. We're giving these a nickname, and it's going to make it easier for us to reference these in the select statement and the on statement by having it a nickname, so we don't have to spell out the whole table. We can just refer to this stocks table as S and the weather table as W. That's what this S and W stand for here. Again, the as is optional. It's probably good to include here. After that, after any aliasing you do, you don't have to alias it. You could still refer to it as stocks and weather and spell it out. But we're going to have the on keyword, which is going to tell us how to join these together. And that's where we specify how to join them together. In this case, and now since we're working with multiple tables, whenever we refer to a particular column, especially if that column is in both tables, it's really good to include the table name or the table alias, in this case, S and W, dot. So it tells us this column comes from this table. From the S table, which we can see as stocks here, it was nicknamed, it was aliased S. From the S table date. This references the date column in the stocks table versus this references the date column in the weather table, which is alias W. So we're telling it when to join, how to join rows together. It's where the date column is the same across those two tables. So that's really important, and it's important that we're joining on date for both of these, for especially the weather table that we're joining to be one row per date, and we validated that was the case when we took the count star and the count distinctive date and made sure those were the same. That told us that weather was one row per date. Found the same thing for stocks as well. So we're joining these together. Again, inner join is only going to include rows that exist in both of those. So basically going to exclude all the days that the stock market was closed. Another option, though, for a join that comes into play sometimes would be to do a left join. What a left join does is it takes all of the rows from the stocks are going to be included in the output. You're in, as long as you're on, it's the left table. It's kind of the firstmost table. If you had it all in the one line, right, this would be to the left of this table. So left join means keep everything from the left table here, stocks in this case, even if it's not in the weather table. And then any columns that you'd be pulling from the weather table, if it didn't have a match on date, they would have null values for those columns coming from the right table, weather in this case. So note that if it's a left join, and there are some cases where there's not a match. And then another option would be the opposite of that, right join. So what this is going to do is keep all the rows from the weather data set, even if they're not in the stocks data set. And like similar to what we talked about before, in this case, any columns we're pulling from stocks, like the close and the open, they would be null. So there would be some cases. So all those days that the stock market was closed, but we had weather for every day, the weekends, for instance, your average temperature, all your other weather variables, they're going to be populated. But any of your stock information, like the open and close, they would be null for those rows if we were doing a right join. In practice, a lot of people try to avoid right joins. Instead of that, it would be written as a left join, and you just swap the tables. So if you really want to do a right join in this case, most people would start with maybe weather as W. So now weather is your left table, and then left join to that stocks as S. Don't have to set it up that way, but this tends to be the way left joins are much more popular than right joins, and they just switch the tables. So this would be equivalent to what we had before, this right join. And then there's one other join type that I'll talk about here among probably the most popular 4 join types. The inner join that we covered first that we'll ultimately use, the left join, right join, again, not very popular because most people just swap the table order. But then there's also this concept of a full outer join, sometimes referred to as just a full join. What this does is it keeps any rows, any dates in particular, since that's what we're joining on, any rows from stocks, any rows from weather, it's going to keep them all regardless of whether the stock rows are in the weather data set or the weather rows are in the stock data set. It's going to keep all the rows. Now, if they have the same date, it's going to join them together based on this criteria. It's not going to create duplicates. But if there's dates that are in the stocks table that's not in the weather table, those will be included. If there's dates in the weather table that aren't in the stocks table, those will be included too, in addition to all the dates where they're in both tables. Everything's included. Now, for the cases where the stocks dates that aren't in the weather data set, the weather columns will be null for those cases. And likewise, the weather dates that don't have a matching date in the stocks data set, the stocks columns will be null for those rows. So keep that in mind, that there could be some null rows in those cases. But in this case, again, we're going to use an inner join and just look at the days when the stock market was open, essentially. So we're pulling a few different variables here. We're pulling the date, the temperature, the precipitation. Notice all of those, we could pull the date from either column here. In fact, let's pull it from w.date as well. We'll give it a different date name here and call it weather date. Maybe we'll call this one as stock date. And we should see that these are the same because we're joining on the fact that they're only going to be merged if they're the same. That's what this on statement is doing. And you can have multiple criteria in here. If you wanted to also say, let's say we had city in the data, both of these data sets as well, we could also say, well, the date has to be the same, but also we don't want to mix and match cities. The city has to be the same too. So you can have all kinds of criteria in your on statement in SQL. In this case, we're pulling date from the stock table and date from the weather table, just to ensure they're the same, but normally just choose one. Need to separate everything by commas, of course. We're pulling from the W table, which is the weather table. We gave an alias of W here, so we didn't have to spell out weather. We didn't have to do that. So that's why we gave it that alias. Pulling temperature, precipitation, and wind speed. And then we're also defining this variable bad weather. But notice this, we're pulling also from the stock table the close and the return, essentially, the close divided by the previous close. So when we run this, we get in one table the variables from our stock data set and the weather data set. We can see in one row, for instance, this first day, May 2nd, okay, the close was this. Now, notice the return is null here because there wasn't a previous row, but we can see the return for May 3rd. This would be 0.45% essentially. So it went up a little bit, very slightly. And we can see exactly what the weather was that day as well. We've brought the data sets together. You can see the dates from the stock table and the weather table are the same by definition because that's how we join them. We validated that. Yeah, we've brought the tables together. This is a really important concept in SQL and data analysis in general. It's where a lot of the meaningful insights come. And SQL does this really well. It's very flexible because this on statement, you can join these on however many criteria as you like, and you can apply functions to these, nest functions within this. You can use between or greater than, all kinds of options for joining tables together. And you could have multiple tables, be joining multiple tables at once too. If you wanted to inner join, or maybe we had another table that we wanted to left join, we just add another join statement here. We can join as many tables as we need to. Now, if the tables are really big, and especially if there's a lot of duplicates, or depending on how you're joining them together, the more joins, the slower your query might get. But most of the time, depending on the SQL engine you're using, it'll be fine. But note that if you ever run into slow query performance, especially left joins tend to be less efficient than inner joins. but sometimes they're necessary for your use case. Sometimes you need to keep all the rows in the leftmost table, regardless of whether they have a match to the other tables you're joining on. All right, let's do our analysis. Let's actually figure out if bad weather tends to have a negative impact on the stock market, for instance. Well, we're going to select and we're going to create our variable right here in our select statement. Same thing we did before. If the weather's less than 40 degrees, if the precipitation is more than 1 inch, or if the wind speed is more than 20 miles per hour, then we're going to consider that to be bad weather. Otherwise, it's not. It'll have a value of 0. We've used a case when statement to define that right here in our select statement. Then we're going to count star. So flag should be going off. Wait a minute, first row here, you didn't do any aggregation on that. You didn't apply any average, min, or max to this variable. You created a variable, but it's at the row level. You haven't aggregated. And now you're going to aggregate. That's a key for you to know. You better be grouping by this variable you just created. And sure enough, we have a group by statement. Remember, whenever you mix and match aggregated variables like count star and non-aggregated variables like this case when statement doesn't have an average, count, or any aggregation applied to it, you need to put in your group by statement any of those variables in your select statement that aren't being aggregated. In this case, it's just that we've defined. And so I would, copy, paste that into my group by statement. In this case, I'll order by that as well. Aggregation, we're just going to see the number of days that fall into the bad weather category versus the non-bad weather category. So that's helpful. Again, 209 days that the stock market's open that we didn't have bad weather, and 41 where there was bad weather. And then we're calculating the return, which is the close divided by the previous close and -1, and we're taking the average of that. So we're aggregating this, so it doesn't need to be in the group by statement either. Just like count and the average return, they're aggregated. We don't need to group by them. In fact, we'd get an error if we did. And so we see here in the output, and same from statement, starting with stocks, inner joining weather. So because of the inner join, we're only getting the rows that are in stocks and weather, only the days that the stock market was open, essentially, just like we did before. And look at the result. We got it down to 2 rows. We can easily see that the average return was about 0.1% increase on the days when there was bad weather. And it was like it was practically a 0%, practically flat over this time period when it was considered to be a nice day. So this would suggest, at first glance, you'd say, wow, actually the weather performs better on the days when the weather's bad. The stock market performs better when the weather's bad, opposite of maybe our hypothesis. But of course, as an analyst, you need to look into whether that's actually statistically significant, and that would be a really good use case for conducting a t-test, which is a topic for another day. But at least at face value, we'd look at this and say, no, actually what we saw is the opposite. I would look at this and say, we might want to look at a longer time period because we don't have a whole lot of data points, especially for the bad weather days. 41's not a whole lot, but also the difference isn't very big. If we saw that, for instance, the bad weather days, if we saw maybe a stock market performance of like 36% increase or something, that'd be really crazy. But if we saw that big of a difference between these two groups, I might say, there might be something here. I'd still want to do my t-test to make sure there was a statistically significant difference. Or we could set up as a regression model and see if the weather variable, the bad weather day, was a statistically significant variable against a target variable of the stock market return that day. That's another way to assess statistical significance. But I want to do that before I said anything. But the larger the difference is between these groups, the more likely I am to say there might be something here. When I see a very small difference like that, I'm thinking, those seem like they're about the same. It's not a huge difference there. But, we could still do the t-test and see if it might be statistically significant. Well, that's a wrap for our SQL analysis. As you can tell, there's all kinds of data manipulations you can do with SQL, which is probably why it's a analytics staple used in nearly every analytics platform. Now that you've learned quite a bit about SQL, there's still more things to learn for sure, but it's probably a good time to actually go about applying what you've learned so far. And one of the ways you can do that is by doing the homework problems that I'll walk you through. Your first homework problem is to use the same Jupyter Notebook we walked through today, the same data sets, to figure out which day during the time period we looked at had the highest daily return in the stock market index that we looked at, the SPY stock market index. Which day had the highest return? In other words, highest close versus the previous day's close. Once you've done that, see if you can get the average daily stock market return by month. So essentially, the same thing you pulled for the highest day before, pull the average stock market return by month. So you should end up with 12 different rows, one per month. Lastly, for this data set, see if you can calculate the total stock market return over this entire time period. If you had bought in the first date in our data set and sold on the last date in our data set, what would the stock market return have been? Now here's your last homework assignment, and this is really where the creativity comes in. Now that you've explored quite a few SQL functions, see if you can maybe take this Jupyter Notebook but adapt it to perhaps a data set of interest for yourself. Maybe it's an Excel file or a CSV file that you import into Python, and then you write all kinds of SQL queries against it to answer certain questions you have. You essentially come up with your own analysis on your own data set. That'd be a great homework problem to really apply what you've learned and really apply SQL in a way that it would be applied on the job. If you liked today's video, I hope you'll consider liking this video formally. And if you'd like to see more trainings on topics like this, perhaps related to data science or Power BI or Python specifically, and even analytics soft skills, please consider subscribing to our channel. And if you have any questions, any errors that come up, anything, please feel free to leave a comment and I'll try my best to get you a good response. Thank you so much for watching, and now it's time to apply your new SQL knowledge.